Hello, and welcome to another video where we discuss our favorite cybersecurity tools for offensive and defensive operations. Today we're going to be discussing Snort IDPS and what that is, what Snort does. It's a intrusion detection and prevention system where essentially what it does, it runs, you can run it on Windows or Linux, and it monitors your network traffic for potential malicious traffic. And today, what we're going to be looking at specifically is Nmap scans. I figured this would be an appropriate follow-up to our last video where we discussed some of the different types of scans utilized by security professionals and network engineers to test ports and identify port versions and that type of thing. So this would be a good video to discuss more of the defensive applications and how to identify those types of scans. So first thing you need is, in my case, what I have here, you can install the Windows binaries from snort.com. In this case, I'm going to be doing it in a Linux Ubuntu server. And on Ubuntu, you're going to want to do sudo install snort in the command line, and this will go out and fetch the snort system. And when you do this, it's going to ask you for your network ID or network range. In my case, it's going to be 56.0/24. For you, it may be something different. And how you can find that, I'll show you as soon as this is done. We can run a ifconfig, and this will tell us our network information or interface information. So we can see under this interface here, we have a 192.168.56 IP address on a 255.255.255.0 network, which is /24 in CIDR. So that is how you find the network information for its setup configuration. So when Snort out of the box, if we were to run Snort straight out of the box, we get some output here where it initializes Snort, and we should see some traffic. Gotta change the network interface. I'm on the wrong one here. Specify your network interface -I, and we're gonna do it on my internal. Let's be 8, and we'll see my current SSH traffic because I'm SSH'd into this server. So we can see we have TCP traffic coming from the server IP address on port 22 back to the Windows machine, which I'm SSH'd in on. So that is what Snort out of the box will do when you run it. Now to fine tune that to where we can only see Nmap related scans or TCP related scans used by Nmap, I have a little rule set here, and I have to quickly just change that IP address real quick to what we have, which is 47. Just replace those. There we go. Okay. So how you would set these rules up, this is the standard format that for each rule that Snort reads. So what our rule is saying here is saying we're going to be doing an alert on TCP protocol. So we're doing a TCP alert from any IP address on any port that's directed to our server here on this IP address. And in this case, I'm going to specify the port as 23, which is normally Telnet, but on modern day systems, generally it's not used because Telnet is a very old protocol and it is a very insecure protocol because it does not use encryption. And in our little parentheses here, we got some a message parameter, and this is going to be what's going to show up in the log. It's gonna this is gonna be like the title of the message. It's gonna say, you know, big letters Nmap TCP scan. We set a signature ID for the rule, which in my case I set it to 102. This could be arbitrary, but do keep in mind that if you have other rules running in the background, other configuration files, these could conflict. So it's good to use something, you know, that's not, you know, like maybe a higher number or something that's may not conflict. But in my case, 102 will work just fine. And then you have a revision number, and the revision number is really just for documentation. Uh, Say if I were to go in and make an update to this rule here for accountability and documentation purposes, when you make a change, it's always good to increment the revision number to say, hey, this rule here has been changed. So that is what the revision number there does. So that's the standard TCP scan. And then we have some other scan types here. We have an XMIS scan, a SYN scan, a FIN scan, and a null scan. So for the XMIS scan, this one I have it listing on port 22, which port 22 is going to be running SSH. As we can see, I've SSH'd in. And the reason why I want to do this one on 22 is because normally when you connect to port 22, you're not going to be using the sequence of TCP flags that the XMIS scan uses. It uses a non-standard really it uses an abnormal way to connect to a port, and this is to, you know, help with testing firewalls and to see if you can evade different firewalls or IDPS solutions, older ones. Snort, of course, you can, you know, if you have this configured, you can see it. But really, in this rule here, we're going to be specifying what flags we want to read monitor for in our connections. And in this case, XMIS uses the F, P, and U flags, which are the FIN flag, the push flag, and the urgent flag, to establish a connection to see if that port's open. Now, standard TCP over SSH, you're going to be using the SYN, the ACK, and the SYN-ACK flags. So if a scanner or if an application is trying to initiate a communication using these flags, then there's a good chance that it's some sort of scan or a fuzzing or some type of you know, potential suspicious traffic. So that is what the XMIS scan is going to do. The SYN scan just uses the SYN flag, which is the S. The FIN scan is going to be using the F flag for FIN. And then the null scan, what that means is that there's going to be no flags enabled. So we're setting that to 0. And this is another abnormal type of scan that if we see that, it could potentially be suspicious. Same thing with the FIN scan. So in that case, I set that to any port. So we're going to listen for a FIN scan and a null scan on any port. So this will generate a bit more output than our other scans here, so we can compare them. So how on the server's end now, we're going to copy this, or if you wish, you can type it out, and we're going to go into the Snort configuration files, and that is under etc snort, and there's a rule directory, and we're gonna add this under the local rules file, and we need to make sure that we're sudo for that. And we can paste these rules in here. And we save it, and they will take effect. So that is where you're going to want to create that, add those files under this directory path in the local.rules file there. And from here, we can begin our packet sniff. And the command for that is going to be sudo snort -a console. And what -a console does, that just tells Snort to send the alerts directly into the console here, into the standard output um, the terminal here. So when something gets flagged, it's going to get reported, and we can see it in our terminal output. That's what the -a is doing there, console. -q, what that's doing is just telling Snort to give us less output than it usually does, so we don't have all that initialization output and the ending report output. It's just going to show us our alerts. -u tells Snort to run under a specific user. So in this case, when you install Snort, it creates a Snort user and a Snort group. So we're saying we want to use the Snort user and Snort group permissions to run the application. -c is our configuration file, and the default configuration file can be found under etc snort.config, and then of course our network interface that we want to sniff on, which in my case is going to be EMP0S8. So if we copy this, we will begin our scan. And right now it is scanning, or sniffing, I mean. And now what we will do is we're going to go over to our other command line here where we have Nmap, and we're going to run our different types of scans to see that those alerts populate in the terminal there. So our first scan we're going to run is just the default TCP scan, and then we're going to be running our null scan, fin scan, and xmiss scan, which uses the -SN, SF, and SX flags. So first we'll just do our Nmap and put in our server's IP address. And if we go into here, we can see that we have a Nmap TCP scan alert here, right? So this is the first, our first one, and we can see that it originated from our Windows machine's IP on this port to port 23. So it hit port 23 on the server. Next, we will demonstrate the other more obscure flags like SX or XMIS scan. And now in here we can see that we have a bit more information. We can see we have our XMIS scan alerts, and we can see the ports in which they were hitting here. So that is the XMIS scan, and we get a classification that says attempted information leak, which just means that it's a potential someone's potentially trying to gather information or perform reconnaissance on the system. Next, we'll do our fin scan, which is SF. If we go into here, we go scroll down a little bit, we see we have some alerts for our fin scan, and we can see all the ports that it hit. Same thing with our null scan, which is SN. That'll be at the bottom here. And this one came up as a fin scan, and then make sure I did that null scan correctly. SN, maybe it's not. Yeah, it's SN. TCP null scan, yeah. Okay, so we see that we have our TCP scan here. So, and a classification of, oh, actually, no, it's not for this one. Okay, so yeah, we can see how these scans, are reported in here, and we can see them and record them. Now, let's say in the event that we want to read from a TCP dump file or a network dump file, we can do that with Snort too. We can parse traffic files instead of having it run on a live interface. So, for example, if we have a TCP dump, and what TCP dump does, it's kind of like Wireshark essentially, where it just sniffs traffic, and we can save it to a file. So we'll do TCP dump -w. We'll do Nmap scan .txt and then -IEMPS00S8. And now we're listening on our interface, and we're going to write our network output to the nmap scan.txt. And if we were to run our xmis scan and we'll do our fin scan, which now those are recorded, we could stop our capture, and in here we have an nmap scan.txt. And if we were to run our snort command here, but instead of using the -I flag, we're going to do a -R and specify our network scan file. And we could see that we have recorded our nmap scan, and we can see our alerts based off of our configured rules on snort. We see our xmis and fin scan flags here, or alerts. So this is some of the very basics, and this is how you would identify Nmap TCP Nmaps scans on Snort IDPS. I wanted to kind of make this as a follow-up video from our previous Nmap video where we discussed the different types of TCP scans that we can conduct, and I figured, one should be made discussing more of the defensive tactics, because Nmap scans are quite common in the field. There's many, bots out there on the internet that perform these Nmap scans, and if you're in the enterprise, you could potentially have a snort system configured to recognize these types of scans. And also, if you were to use it inline, where you have it between like a file server, a web server, and like a router, you could potentially, be using the intrusion prevention system as well, and block those connections coming in if they were detected. So for today, this was how to set up snort, and how to detect Nmap TCP scans. I hope this was informative, and everybody have a great day.